research analyst at Placeholder Ventures, which is a crypto-native venture fund based out in New York City. And today I wanted to talk a little bit and provide some clarity on the whole crypto AI vertical and really break it down to its bare bones technical level. There's been a lot of talk about and excitement about crypto and AI and how the two intersect. And I think today I'm going to put a little bit more of a somber tone and break it down to its technicals on where the crypto stack helps AI and where the AI stack helps crypto. So where I want to start is by defining what I believe the AI stack consists of. Right? On your bottom, you have your compute, your data layers. Right above that, you have your training layers, which is essentially taking in the raw goods and processing it into something useful. On top of that, you have your dev tools, your inferencing providers, and at the top, you have developers creating applications and agents that leverage these training and inference infrastructures to create something valuable for us everyday users. And I'd like to focus on the bottom two, the compute, data, as well as the training layers. Now, a lot of folks have probably mentioned the fact that we can decentralize some of these training, these compute, these data collection mechanisms, but the question is why? It seems that we're decentralizing for the sake of decentralizing without considering the performance and efficiency trade-offs for doing so. And my thesis here is that centralized providers currently that collect data, that house compute resources, and therefore translate those into training foundation models currently do and will continue to have an advantage as compared to our decentralized counterparts. And the reason for that, just pure economics and scarcity. If we think about it today, demand for top-line hardware, data, and compute resources will always outpace supply. And since those are the primary ingredients in creating training resources, what we'll see is that centralized providers will continue to outcompete and outperform decentralized counterparts, at least for the foreseeable future. What this lends itself to is an observation that scarcity for top-line hardware, data, and capital equates to centralization within our most performant foundation models. And this is going to continue happening. You have your NVIDIA chips now in their current V1. You have V2, V3, V100 versions of these coming out. And the top-line providers will always have a higher demand as compared to supply for some of these compute resources, thereby leading to centralization at the most fundamental training, compute, and data locations. Now, this kind of puts a bleak outlook for the future of decentralized compute and training layers. But I'm here to tell you that it's not all bad. What we'll find is that when you start generating these different versions of top-line hardware, it's not like the older hardware is now suddenly moot or useless, right? The top-line hardware is only supporting the most performant top-line models. But what happens to the older hardware that works perfectly fine, but just for older use cases? Well, I believe that it finds allocative efficiency. So as you can see here, we see old hardware that's supporting mid-tier models as compared to and then services decentralized compute networks, therefore servicing on-prem and edge models, personal data sets, and maybe smaller tasks. Now on the other side, what we see is top-line models. These top-line models, sorry, let me make sure I'm presenting this properly. There we go. So these top-line models, therefore, will service more complex models. Therefore, will be centralized and might be centrally hosted complex performance tasks. Now, an easy way to walk y'all through this is, let's say I'm a personal user, and I'm using my iPhone to execute a simple task. Maybe I want to book an airline. Do I really need NVIDIA's H100 chip for me to execute a task on Expedia? Probably not. And so what I'm probably doing is, okay, we have old hardware on my edge device, serviced from mid-tier models that can fulfill said task and are good enough to do so. They're able to run on decentralized compute and training networks because it's cheaper, more affordable, and more flexible than its centralized counterparts. And it can exist on our edge and can service our personal data. On the other hand, let's say I'm executing an incredibly complex task. Maybe in this case, my iPhone that's running some edge model can't service said task. What we can imagine then is my iPhone or my edge device obfuscates my personal data, my personal identity, and my personal request sends it to a complex model, maybe hosted in a centralized way, because that's what their advantage is. It's run on a centralized training model, and therefore can perform more complex performance tasks. Now, moving on from here, what we see is this thesis that maybe the factors that we're competing on for decentralized training and decentralized compute are incorrect. If you think about what people are marketing themselves as today, they're saying, we're going to become the next OpenAI. We're going to essentially replace what folks are building on, the OpenAIs, the Microsofts, the Googles of the world. Maybe the factors that we want to compete on instead is, look, those guys have the most performant hardware. They have the most performant data. That's great. Good for them, and that's where they can operate. But what we on the decentralized area really compete on is verifiability, flexibility, and censorship resistance, and to a certain extent, affordability. And I think if we continue harping down on those areas, that's where we'll see our advantages. Now, moving on, we can see that this lends itself to an eventual transition in the training model. Currently, our decentralized training models are censorship resistant, and that's great for them. On the centralized part, we have potentially biased and centrally run models. And we can see that that's a relative market share split. Most of the decentralized models are run by hobbyists, independent researchers, and startups, whereas most of us use the OpenAIs of the world. What we could see, though, is a transition to this future, where decentralized models end up capturing most of the mindshare for our individual users. And then centralized models are potentially biased and centrally run, but are reserved for top-line performant and complex tasks. And so it doesn't have to be a centralized versus decentralized. It could be that they exist together. Now we move on to inferencing. So let's move one layer above on the stack. Right now, it's the same thing with inferencing models that run on top of decentralized or centralized training models. They offer zero downtime, public evaluation and reputation scores, and a set of diverse outputs. On the centralized side, though, there's bias, vendor lock-in, a lack of verifiability. We're placing trust in these actors because we have no other option. But again, if we focus on competing about censorship resistance, we focus on competing on the factor of affordability and flexibility, we can exist in this future where most user requests for inferencing are completed by decentralized inferencing providers, and only the most complex requests are completed by your centralized counterparts. Again, this whole thesis of coexisting rather than one against the other. Now, what this lends me to is a thesis that I express in a blog post, which y'all can read online as well, that decentralized compute networks and inferencing networks present a unique value proposition around more personalized, affordable, openly competitive, and censorship-resistant AI. And I think these are the factors that we have to compete against to eventually gain market share against our centralized counterparts, as compared to butting heads with them, rather treating them as equals and therefore coexisting with them for certain tasks. Now, before I end my speech, I would like to say that there's a lot of innovation that I've seen at this ETHDenver, specifically on the agentic app layer. And a little bit of a thesis there is, you could imagine, as I said before, you operating with your iPhone or another edge device and fulfilling requests in natural language, and therefore not having to deal with the complexity of finding resources yourself, but rather just speaking it into existence. Now, how does that coordination at that agentic layer happen? I think that's a really cool question to answer. Anything around agent discovery, agentic coordination, and communication. So if y'all are building in that space, researching in that space, feel free to get in touch. That's my Twitter over there, and more than happy to talk about it afterwards as well. Appreciate y'all's time. Appreciate ETHDenver for having me out here. Thanks again.